In this video, I introduce a PixelCNN for raw audio generation. Wavenet is a deep neural network for generating raw audio waveforms, which is a fully probabilistic and autoregressive model. The audio distribution for each audio sample is generated condition on all previous samples. The joint probability Px of a waveform X is expressed as a product of conditional probabilities. Wavenet uses a stack of convolution layers to model conditional probabilities. Here is a training procedure. Causal convolution reinforces the possibility to predict the current data xt without using the future data from xt plus 1 to x capital T. If a receptive field of output is 5, the output at T10 is a condition on his previous inputs from 6 to 9. To use all previous data as an input to predict the current data, namely to increase the receptive field of the current output data, we need to use a larger dilation rate in convolutional neural network. If a dilation rate is equal to n, we need to insert n-1 0 between the adjacent data. For example, a stack of convolutions 1, 2, 4, 8 here are used to increase the receptive field. Using the dilation convolution, the output at T16 has a receptive field with his previous inputs from 1 to 15. If a raw audio is stored as a sequence of 16-bit integer, a softmax layer needs to output 65,536 probabilities to model all possible values. A mu law companding transformation is applied to audio data so that the softmax layer only to output a distribution over to 56 possible values. The nonlinear formulation produces much better reconstructions than linear transformation. The inverse mu law is defined as here, which is used to recover the generated audio waveform with the 16-bit integer representation. The gated PixelCNN generates the output Z using the gated convolution layer, where F and G are filter and gate respectively, and W is a kernel matrix to be determined. First, we use the one-hot vector as our input, causal convolution layer. Use a mask to remove the contribution from the future samples. This gate is used to control information to predict the output xt. For more details, please check with these references. Thank you. Bye.